My name is Mohammed Tariq, and this lecture is about visual representation of disjoint set. I'm using the site visualgo.net for showing you the animated representation of the disjoint set data structure. So I have some functions here. I have initialize function. I can use initialize to initialize the disjoint set. Then I have find set. Using this, I can find the set is same set. So this method will compare two elements and will give me a result like are they in the same set or are they different. And then I have union set. So let's first initialize some disjoint sets, and I can say here let's initialize 7 elements. I am initializing 7 elements. So as you can see here, I have 0 to 6 elements. So these are sets, and these sets containing only one element, right? So now let's perform the union operation. So here I have two values I and j. So I can here give the number that which set I want to join, which two disjoint sets I want to union. So let's say first I'll say 2 and 2 and let's say 4. I want to union 2 and 4. So as you can see, it's 2, it has found 2 and it has found 4, and then it will join them. So this is the final result. And here on the right hand side, this is the algorithm which is working, and it's showing the movement of the lines, the execution of the line. So union let's union um 3 and 5. Okay, let's union 3 and 5. So I have 3 here. I will say 5, and now it's going to group 3 and 5. So it has found both the elements. Now it's a union. And here in the first set, 4 is the representative, or you can say the 4 is the root node. And same on the second set, we have 5 as a representative of this whole set. Okay, now let's union 2 and 6. Okay, we have 2 here and we have 6 here. Now let's union 2 and 6. So 2's root node is 4, and 6 is the individual node. It is itself is a root node. So it will combine these two, 4 and 6, right? Okay, now let's combine 1 0 and 1. Let's do 0 and 1. 0 and 1. So here we have 0, and then we have 1, and then it will unite these two, and it will make, I guess, 1 will be the root node. Yeah, it is making the greater values as the root node. Okay, now let's combine 6 and 1. Okay, let's combine 6 and 1. So 6 root is 4, and 1 is the root node itself. So now it will make connection 1 and 4. So as you see, the root is now 1, and the 4 is the child of 1. Okay, now let's union between 0 and 5. Okay, now let's say 0 and we have 5. So zero's root node is 1, 5 is the root itself, and now it will unite them. So now we have now all the elements have become the part of one set. And now let's apply path compression here. For path compression, let's say I'm saying that is 6, 6, and let's say 3. I'm calling the method is same set. So I'm trying to check is 6 and 3 is in the same set. 6 and 3, both these values are in the same set, then it will apply rotation, right? So here it's 6, 6 root is 4, and the 4 root is 1. And now you see it has compressed the path. And 3, 3's root is 5, and 5 root is 1. And now it will apply the compression with 3, right? So now both 3 and 6 are directly pointing to 1. It is applying path compression on find method, right? So here we have used is same set, and when using this method, when we call this method, it checks that is there any node which needs to be combined to the root node, which any node on which path compression can be applied, so this method applies the compression on that node. Okay, in the same way we can do with 4 and 2. So I can say 4 and 2, and it will check that is there a node in this tree which needs to be compressed, and it will do the compression. 4, 4's root is 1, that's fine. And then it will check for 2. Now the 2's no root is 4, and then it's 1. So now this is the candidate for compression. 2 is the candidate, and as you saw, it has compressed the tree. Now this is a very perfect disjoint set, and this will give us the constant time if we find any node. So let's say if we find any node, so okay, the find set will again, this is just a simple finding 4, and it will give me the root node. So this is how this disjoint set works, and this visual representation is always very helpful for students in understanding the working of the data structure. I hope this will be helpful for you, and I will see you in next lecture. Thank you.